methyl, hydrogen, ethyl, propyl. 4 different groups attached to this carbon, and he just drew the mirror image of it to show that it was an optical isomer. How would you name that molecule? Forgetting about the G's and the L's that we're not going to do that. Because we already know how to name them. First of all, it's an alkane, right?
Yeah.
So we want to find the longest carbon chain.
Just 3.
1, 2, 3, 4, 5, 6. Right? Constituent. So it's 1, 2, 3. 3 methyl. Hexane. And that's 3 methyl hexane also. So we distinguish them with either use plus or minuses if we do have rotated between the polarized light. There's one other way of distinguishing between the different optical isomers, and it goes back to a parent compound. You do a set of synthesis steps, and if you follow the chemical reactions properly, it will relate it back to the parent compound. Again, that's something we don't do. Questions? Yes?
I don't understand why that molecule is atrial, the one behind you.
This one right here?
Yeah.
I said this terminology, it means that it doesn't have an optically active center. It's a more general term. These are definite mirror images, but there's free rotation here. These 2 groups are the same. Hydrogen, hydrogen. It's not asymmetric. You can't have optical isomerism.
How come the bromo and the chloro don't make it asymmetric?
The secret is 4 different groups. These 2 are the same.
Okay.
Does he have another example? I think he has earlier than that. No, he doesn't. Oh, there we go. I didn't go far enough. Here's Kiro. There's 1, 2, 3, 4 groups. There's the mirror image. That's just the way of drawing it. Here you have 2 groups the same. It's A Kiro. Here again, ethyl, methyl, hydrogen, hydroxide. 4 different groups. That's what you always look for the chiral carbon. Okay? Or the asymmetric carbon. That's why I like the term asymmetric, because it means there's 4 different groups. There's no plane of symmetry. If I did this sort of thing, cutting along this bond, it's symmetrical on either side. What?
I see.
In other words, it's a 3-dimensional thing, so I'm cutting in through here, so I'm going through this, and it splits between the 2 hydrogens, so it's symmetrical on both sides. The easiest thing is 4 different groups, because we're not going to get into it where we have to do much more than that. Going to those sugars. I look at this. There's a hydrogen, a hydroxide, an alcohol group, and this thing. 4 different groups. This is also asymmetric here, because there's hydroxide, hydrogen, this structure, and the aldehyde. Okay? That's all we're looking for, 4 different groups. I just used iodine and everything, but I could have put methyls and all sorts of junk on there, but it took me long enough to do that. And we're not going to worry about naming sugars either. There are hundreds of sugars you can draw, but we'll talk about that. Okay, what else do I want to do? I'll get something else up here, because I want to move on in functional groups. I'm going to start doing some chemical reaction. It's going to go faster if I do this thing.